guys, good evening. So one of your friends actually had a question regarding wait, hold on. Okay, regarding this multivariable function fxy equals to x squared y plus ln y squared minus x. So this is the question in here, and your friend was wondering how do we find fxy. Okay, how do you find fxy in this case? So first of all, okay, fxy actually means that you have to find del f del x, right? And then later you have to differentiate it with respect to y, partial differential. Okay, so first steps first, let's find fx. Okay, so we're going to differentiate each of the terms right here. So the first term here is x squared y. Okay, so when you differentiate it with respect to x, it would just be 2x times y, because y is just a constant. Okay, and the second term here, ln y squared minus x, if you are differentiating with respect to x, okay, don't forget the plus sign by the way. Okay, we're differentiating with respect to x. Okay, so you can treat the y squared as some constant. So imagine it's just simply ln 2 minus x. Okay, and then you just use the basic chain rule. Okay, so if you find the derivative of it, so just d dx of ln 2x is just equivalent to 1 over 2 minus x times negative 1. Okay, in other words, it becomes negative 1 over 2 minus x. So similarly, for this case, it would be what? It would be negative 1 minus y squared minus x. Okay, so that is your fx. And if you want to simplify even further, we can, a little bit simplify it. So we'll end up having 2xy minus 1 over y squared minus x. Okay, great. So now we want to find fxy. How are we going to find fxy? Of course, we have to differentiate fx with respect to y, right? So I'm going to erase this a little bit just to clear some space. Okay, since we're differentiating with respect to y, let's consider our two terms here. First is the 2xy, okay, and the second term here is this right here. Okay, so the first term is relatively very easy. So for fxy, okay, since we're differentiating with respect to y, and the 2x actually you can treat it as some constant. Okay, so this will act as a constant anyway, so this will be a constant. So since it's a constant, it will just be 2x. Alright, and then for the second term, since it's 1 over y squared minus x, you can treat it also like this. Like an equivalent way of treating in partial differential would be 1 over y squared minus 2. So how would you differentiate this function? So you can write it as y squared minus 2 to the power of negative 1. And when you differentiate that using the chain rule, for example, you find the derivative of this function using the chain rule, the out and in rule that we talked about earlier. So it becomes negative y squared minus 2, because the power negative 1, it sort of went there, right? So negative y squared minus 2 multiplied by 2y. You differentiate the inside. So you'll end up what? You'll have negative 2y. And don't forget, so it becomes to the power of negative 2. 2y times y squared to the power of y squared minus 2 to the power of negative 2. Okay, so if negative 2 was your x earlier, right, we took the x as negative 2. So we're going to replace it back with, so it becomes minus here. So it becomes negative 2y y to the power of 2 minus 2 to the power of negative 2. okay, then it would become 2x plus 2y over y square minus 2 to the power of 2. So that is your fxy actually. Okay, oh, sorry, not 2, my apologies, supposed to be x, by the way, because I just replaced the 2 with the x here. My apologies for that. So it was supposed to be x, okay, because we're doing partial differential, so we treat it that way, so it becomes x. So yeah, that's how you do it actually. How you do the second order derivative. The first one, you just simply differentiate the multivariable function with respect to x. Then after that, you differentiate it with respect to y, and this is your final answer. Now, okay, let's say if you want to do it a little bit differently, let's say for example you wanted to differentiate this part a little bit differently, we can also. Okay, so let's do it. Okay, so of course for fxy, the first part would obviously be just 2x because y will be differentiated out. But for the second part, let's use the quotient rule. Okay, let's treat it as our u and let's treat it as our v. Okay, so of course our quotient rule will become v del u del y minus u del v over del y over v squared. Okay, so likewise we're gonna do is gonna be y squared minus x times del u over del y, which is obviously gonna be, well, 0. Okay, so minus with u, so that's 1, del v over del y is just 2y, okay, over y square minus x to the power of 2. So as you find fxy, it will just become 2x minus, and by the way, this will become 0, by the way, so this will be 0. So we're left with negative 2y, okay, over y square minus x to the power of 2. And then as you simplify it, you would have fxy equals to 2x plus 2y over y square minus x squared. Okay, so this is your final answer. You can do the first method, or maybe if you also prefer to do the quotient rule, also the second method, it's completely fine actually, because they'll both lead you to the same answer. Okay, and yeah, hopefully this video clears it up. Again, see you.